Serial Line Internet Protocol (SLIP) was fundamental in the early days of the Internet, dating back to 1984, with the Unix or Linux environment leading the charge. You see, SLIP was an industry standard protocol developed for Unix environments that supported TCP/IP networking over serial transmission lines, typically dial-up connections using a modem. Fundamentally, this SLIP protocol allows TCP/IP hosts to access the Internet via dial-up through SLIP servers located at the Internet Service Provider (ISP). This concept back then was significant, even pioneering for its time, leading in its early role in Internet connectivity, enabling devices to communicate over telephone lines, a foundational step in the development of our today's network communication technologies, aka long before the advent of broadband and wireless technologies. Now, some historical context. Back then, serial ports were the primary ports used to connect modems, printers, terminals, peripheral devices, etc., aka the original USB ports. All computer operating systems in use today still support serial ports because these have been around for decades. Technical keynote: first came serial ports, then came parallel ports, and then came USB ports. And the name serial comes from the fact that a serial port serializes the data, an important technical concept to understand as we go throughout this video. So a Unix system that supports the IP and TCP protocols will push these through a serial port which connects to a dial-up modem, which then connects to a phone line, which then connects to a public switch telephone network (PSTN), or plain old telephone service (POTS), which was covered in a previous video which is linked and flashing on your screen now. I appreciate as these old telecommunication networks are largely being phased out today in 2020 onwards. I have tried Googling this topic and also reading on Wikipedia, but I found the dry, contextless summaries as plain boring, almost as plain as the plain old telephone service. Oh yeah. Hence, I wanted to make this modernized, cool video. And if you would like to see more videos like this, please show your support by leaving a like and subscribing to the channel if not already, which helps support the channel's continued growth. Now, back to the video. Let's visualize how the TCP IP packets can be shot down the serial port which goes down the serial line across the telephone network. The importance of the serial line Internet protocol cannot be understated by enabling the encapsulation of datagrams over these serial lines, aka telephone network. In fact, it was so revolutionary that its simplicity and ease of implementation made it a popular choice among early Internet users and providers. So much so that Microsoft Windows 98 and XP supported the SLIP protocol. However, SLIP was not without its own issues. However, for the most part, SLIP's legacy is understood by its contribution to the evolution of Internet accessibility, serving as a stepping stone towards more sophisticated and efficient networking protocols. Now, in the next part of this video, we shall look at the dark side of the SLIP protocol, which eventually led to its demise. You see, the SLIP protocol was a quick and dirty solution to transfer datagrams over serial lines, but this came at a cost of missing many features that are needed in such a protocol, such as error correction, authentication, compression, and even IP addressing, just to name a few. To understand how the SLIP limitations ultimately led to its demise, we must get a little more technical by firstly understanding the structure of a SLIP frame or packet. Now, this is a very dry topic, so please bear with me, folks, but I promise I will make it cool as we go along. Now, as you may recall from early in the video, I mentioned the concept of serialization being a key concept to remember. Well, this is why. When it comes to the serial data frame structure, which looks something like this. The frame structure starts with what is known as a start bit, which is usually a zero value, and is then preceded with the data, usually 8 bits, aka 1 byte, followed by an optional parity bit and then some stop bits or bit. There are some exceptions and nuances, of course, which I have listed here. Furthermore, here is a bonus exam tip around the notation of how this SLIP protocol was referred to back in the day. So when we say 8N1, this means that there are 8 data bits, no parity bit, and 1 stop bit. Easy, right? So knowing this, let's use another example. Please feel free to pause the video to have a go at this yourself. The answer represents 7 data bits, even parity, and 2 stop bits. So going back to the serial data frame, this goes into the serial port. However, important technical keynote, it does not go in as a byte, it goes in as bits, starting with the start bit. Then the data bits, one by one, then the optional parity bit, and then the end bit. Remember, the data bits, aka the data payload in the middle, is framed between the start bit and the stop bit, aka end bit. But only the data bits are processed by the computer. The start and end bit is ripped apart during the encapsulation across the wire. To learn more about networking encapsulation and decapsulation processes, please refer to my previous video on the OSI 7-layer model, linked here. Now, the cool visualization of this whole entire serial line process. Imagine a funnel where we need to put this serial data frame format through. To do this, we do this bit by bit, sequentially, starting with the start bit, which is of 0 value. We push this through the serial port, down the serial line, through the modem, into the phone line, and across the internet. We then do the same with the rest of the frame, such as the data bits, and I mean bits, 1 bit at a time. This is a limitation of the serial port. We cannot send the byte down the line, we can send it bit by bit. And once we are finished, we send the final stop bit or bits to indicate the end of the frame. And just to clarify, the parity bit is optional. And now, for those still watching, here is a cool recap. In all my research of the SLIP protocol and from reading the RFC Request for Comments 1055 in June 1988, the author goes as far as to say, don't use this, something better is coming. I am not joking here. The SLIP protocol is absolutely nothing more than IP packets shot down a serial line raw with 2-byte sequence called end at the end of each one, which is referred to as framing, but is not really framing. As we found earlier, it lacks a lot of consistent features and some basic authentication. It was made as a quick and dirty shotgun approach to shoot serial data frames down a serial line to go down the phone lines. That back then was revolutionary and the first ever access to the internet, which today we take for granted. Whilst the original SLIP RFC could be read for serial laughs, the real solution came in the form of an enhanced protocol, which still exists today, known as point-to-point protocol, which at the time of creating this video, I will need to make another video on, given I have managed to fully fill out an entire video on SLIP in such a simplistic and cool way which never existed during all my boring research. I do hope you enjoyed today's content and found it informative. If you did, it would be super fantastic if you could leave a like and subscribe to this channel to help support its continued growth whilst I work on the next video for PPP.